Hi guys, welcome back to the Ribe, and again I'm Engineer HB and we're going to answer past board exam problems. Still andito pa rin tayo sa machine design, which is sana ay maging helpful sa inyo. Andito tayo sa chapter 9, which is the topic of columns. So our usual way of discussion is syempre bago tayo magsagot ng mga problems ay formula review muna tayo. So let us start this. Okay, so columns. Ano nga muna ba ang column? So a column is a member under compression whose failure is due to instability called buckling or bending sideways. So kagaya ng picture na ito this is a member who's under compression. So nakikita nyo, yung force is for compression. Pero yung failure niya is due to instability called buckling or bending sideways. So parang ang nangyari sa normal na compression, kung meron tayong ganitong member, kinompress. So ang mangyayari is, of course, iiksi yung member. And siguro lalapad din. Okay, so that's the normal scenario when a member is under compression. Pero ito namang column, compression siya, pero ang nangyari sa kanya is nagbabuckled siya sideways. So pumapaling siya. Ayan. So of course columns ay mahaba yan. No, and syempre nag-apply ka ng force, meron siyang effective length which will be discussed later. So in order to test kung ano bang uri ng column ang meron sa isang problem, so meron yan mamaya sa mga susunod na slides, meron tayong tinatawag na slenderness ratio or the ratio of the effective length over the radius of gyration of its cross section. So we all know that the radius of gyration way back on our engineering mechanics is simply the square root of the moment of inertia divided by the cross section area. And since columns are usually has a cross sectional shape or shape of a circle, we all know that the moment of inertia for a circle is pi over 64 d raised to 4 at ang area niya is pi over 4 d squared. So para mas ma-simplify natin yung mga problems, just divide the moment of inertia over area, and ang lalabas dyan, square root nun, ang lalabas dyan is simply diameter over 4, right? And syempre kapag hollow circular cross-section naman, syempre this is for solid, at kung hollow naman, it is simply the square root of the square of the sum of the two diameters, the inside and the outside, and just divided it by 4. So for simplification lang naman itong dalawang ito, kasi nga ang kadalasang case ay ang kadalasang cross-section ng mga problems is a circular cross-section. And of course, if this is your radius of gyration, meron din tayong tinatawag na effective length, which is meron ding mga types na kino-consider. So meron yan mamaya. So that was the test and the first procedure in every problem. So determine the slenderness ratio. Kasi kada types ay may formula. And we have this other formula, the transition point. So that was also the slenderness ratio, pero may subscript na transition point, and that is equivalent to square root of 2 pi squared e over sy. So dalawang property ang bida dito, kaya ito ay tinawag na transition point. One is the e, which is the modulus of elasticity, and the sy, which is the yield stress. Okay. So this is a dimensionless formula or unit kasi nga this is laging naka-pascals or gigapascals. Ito namang SY laging naka-megapascals. Yung E naman lagi, minsan given gigapascals. So just convert this megapascal into gigapascal, or the other way around, this gigapascal convert to megapascal. So the unit will be cancelled, and this is a dimensionless. Okay? So how about the members under compression? So bulol na. So we have these three types. No, we have these three types na madedetermine natin ano bang uri ng column ang meron. So we have these three types. At kaya ko sinabi kanina na the first procedure in every column problems is to get the slenderness ratio. So how about that? So we have these three, the short compression member. So ang short compression member daw, kapag ang slenderness ratio niya is less than 30, ang sabi, it is not possible to fail by buckling or no column action. So the formula for the stress is simply force over area. Ano ang meaning nun? Kapag daw ang slenderness ratio is less than 30, ang sabi kunyari, ito daw yung member, hindi daw posible na mag-fail by buckling. Pero by simply compression lang, which is the normal scenario for every compression problem. So that was only equivalent to compression stress is equal to force over area. So ganun lang simple. So how about this second type, which is the long and slender column? So paano natin masasabing long and slender column? So para mas madaling matandaan, long column na lang. So the slenderness ratio daw is greater than 120. And the failure is due to instability. Siguro, kaya ang failure nito is due to instability kasi nga, from the word itself, long column. Kunyari, we have a fixed wall here, tas gantong kahaba yung poste mo. Kunyari, 10 meters. So that was long, di ba? So, syempre, magfe-fail talaga siya due to instability kapag nag-apply ng force. So, siguro magaganyan yung bending niya. And that is equivalent to compressive stress is equal to F over A again. Syempre, may F over A ka lagi dyan. Ang problema ay may nadagdag lang na konting factor, which is the factor for column action, which is Euler's formula. And that was equivalent to slenderness ratio, square mo lang yan, divided by pi squared EA. So the unit analysis will be discussed on the problems na lang in order to shorten the time of discussion. And the third type is the short column. So ang malilito, ito ay short compression. So ito naman ay short column. So kasi kung may long ka dito, meron ka ding short. And the slenderness ratio daw ay nasa gitna ng 30 to 120. The slenderness ratio is greater than 30 but less than 120. Kung ang slenderness ratio mo ay 50, then it is a short column. 50, 60, 70, 80, 90, 100. And syempre kapag nag-121, of course, that is equivalent na sa long column. And syempre, the compression stress is also equivalent to F over A again. Pero syempre, lagyan lang natin ng factor na JBJ, which is known for factor for column action, comes from J.B. Johnson's formula. If the long column comes from Euler, this is from J.B. Johnson's naman. That is equivalent to 1 over 1 minus SY times the slenderness ratio squared over 4 pi squared E. And notice that this letter B, the long column, ang bida dyan is itong E, which is modulus of elasticity. At dito naman sa short column, ang bida is si modulus of elasticity at si yield stress. And if you are going to take problems for columns, I think para sa akin, I'm wish na laging long column, no? Kasi mas maiksi yung formula niya. Hindi kagaya dito. Anyway, we're going to see on the next problems. So how about this? So effective length of columns. So that was equivalent to LE is equal to L over square root of N. Ibig sabihin kapag may given pala agad na length, hindi pala agad yun yung effective length. Why? Kasi nga, depende kung saan nakakabit yung poste. And we have this N is equal to N fixity coefficient. So we're going to see on this next slide. So that this is the effective length of column. So I'm going to write again the formula of effective length is equal to the ratio of the total length over square root of N fixity coefficient. So we have these four types. No, two ends fixed. Ibig sabihin ito, fixed. Kinakabitan ng poste. At kung meron siyang total length na L, compressed by force F, meron siyang equivalent length na kalahati ng total length, which is LE is equal to 0.5 L. And the N fixity coefficient is N is equal to 4. So we're going to see if this is correct. So if this LE, and in this letter A case, so the Wait lang, burahin natin. So the equivalent length daw is 0.5 L. And of course, meron tayong L here, square root of N. So it is cancelled. So mangyayari niyan is N is equal to 1 over 0.5. And that is equal to 2. So ibig sabihin, square root of N is equal to 2. So that was N is equal to 4. So it is correct. So it can be, the fixity coefficient can be derived based on this formula. So kailangan mo lang tandaan siguro kung ano yung pinanghahawakan ng poste, and just remember this effective lengths, or just remember the fixity coefficient, or the other way around. So dito lang iikot yung formula and pwede mo nang matandaan yung effective length or fixity coefficient. So how about this letter B? So kapag ang 1n naman daw ay fixed, ito yung fixed, at ang 1n mo naman daw ay pinned or rounded, so the effective length is 0.707 L and the fixity coefficient is 2. Okay? So you may write this 0.707 as square root of 2 over 2. And letter C, third type, kapag parehas namang rounded or pinned yung both ends, so the effective length is equal to L. Ayan, ibig sabihin, kahit apply mo ng force F, your total length is also equivalent to LE. Of course, N is equal to 1. And this lastly, if the one end fixed and the other free end, the equivalent length is equal to 2L or twice ng total length, and N is equal to 1/4. Kasi nga dito 4 ka, kasi may 0.5 ka dito. Eh ngayon naging twice, so madidivide lang sa ayan, magiging magre-reciprocal lang tong N is equal to 4 man dito. Basta lahat ng formulas dito ay umiikot sa formula na to. LE or equivalent length is equal to total length over square root of N fixity coefficient. And lastly, we have these column formulas, no, na nakatuon naman sa forces. Okay? So, kapag ang column mo is based on long columns, syempre kanina, bida dyan ng Euler equation. So, we have this critical force na tinatawag. And critical force is also equivalent to force times factor of safety. And that is also equivalent to pi squared EA over LE over K squared. So this is your slenderness ratio. Okay, and this is your modulus of elasticity. And this is your area. So this is dimensionless. And we all know that the E is, kunyari, Newton per mm squared. And you have your cross-sectional area in mm squared. So that was cancelled. So ang unit nito is Newton. So tama lang yung formula na ito. And in order for you to memorize this one, just back to the column factor, which is ito. So ipag-reciprocalin mo lang siya. So that was SR squared or slenderness ratio squared over pi squared EA. So magiging pi squared EA over slenderness ratio squared. Kasi nga force naman ang tinutukoy dito. At kapag JB Johnson's naman, and that was applicable to short columns, again, that was 30 is less than LE over K and is also less than 120. So the formula for the critical force is, again, force times factor of safety, and it's also equivalent to yield stress times area times i-reciprocal mo lang yung factor kanina na JBJ. And there you have it. Kasi nga, di ba, parang nag-ano ka lang. Force is equal to stress times area. So this is your yield stress and this is your area. And samahan mo lang ng konting factor. May konti. Tingin mo konti ba to? So, ibig sabihin, samahan mo lang ng factor, which is reciprocal nung JBJ. Okay, so ayan, ibibilin ko lang sa inyo yung pag-memorize nitong formulas. Okay, so halika, proceed tayo sa problems. So, number 1, What is the transition point between the Euler's formula and the J.B.Johnson's equation for a column material having an yield stress of 259 megapascals and modulus of elasticity of 70 gigapascals? On the first slide of the formula, we all know that the transition point is equivalent to the slenderness ratio. Transition point is equal to 2 pi squared E divided by SY. Tama ba? 2 pi squared E over SY. So, kailangan magparehas lang yung unit nito para it will be dimensionless. So, that is equivalent to square root of 2 pi squared E. So, that was 70 gigapascal. Just multiply it by 1,000 in order to become megapascal. And of course, you have your 259 megapascals sa ilalim. So the answer is 2 pi squared times 70k divide 259, square root nun. So the answer is 73.04. So that was the transition point between the Euler's formula and the J.B.Johnson's equation. So parang lumalabas slenderness ratio mo. Kaya nga ibig sabihin ng transition point, di ba? Ang short column mo is ganito, 30 is less than slenderness ratio and less than 120. And since your transition point is 73, ibig sabihin ito daw yung point which is papunta na si Euler kay J.B. Johnson or the other way around. Okay? So the answer is 73.04. Second, determine the radius of gyration of a short compression member having an allowable stress of 50 KSI with a force of 30,000 pounds. So be noted that the member is a short compression member. Remember, we have three: short compression, the long and slender column, and the short column. So wag malilito sa first and third type. Short compression member is simply SC is equal to the ratio of force over area. At if meron kang given na allowable stress or stress of 50 KSI, so that was 50,000 PSI or pounds per square inch is equal to force, which is 30,000 pounds. And of course, we have this area, which is pi over 4 d squared. So para saan natin kukunin yung area or yung diameter? Remember that the radius of gyration, basta given ay circular cross-section, so the equation is square root of I over A. And since this is a this is a solid circle, so simply K is equal to D over 4. So we're going to get the diameter first. At kapag nakuha natin, divide by 4, and we already have our radius of gyration. So the diameter here is 30K over 50K times 4 divide pi. Square root mo yun. So you have 0.87 inches. And of course, the radius of gyration will be 0.874 divide 4. The radius of gyration is 0.2185 inches. Remember that the radius of gyration is always has a unit of inches only, not a square inch, not a cubic inch, but inch only. Kasi meron ka ditong inches raised to 4, meron ka ritong inches squared, matitira inches squared, square root mo yun, so that will be in inches. Same in metric. So our radius of gyration here is approximately equal to 0.22. So the answer is letter C, 0.22. Okay, so proceed tayo sa third question. What is the slenderness ratio of a column? One end fixed and one end pinned, having a total length of 2.5 meters, having a cross-sectional area of 1,250 square millimeters. So we're looking for the slenderness ratio of column. Ang sabi, one end fixed and one end is pinned. Okay, so meron tayong second type kanina, which is the same as this one, and fixed. and one end is pinned or rounded. So the effective length dyan ay, we all know that the effective length is 0.707 of the total length, and we are looking for the slenderness ratio, and that is equivalent to effective length over K. And we have already effective length, which is 0.707 ng total length over K, which is, we all know that K is D over 4 for a regular circular cross-sectional area. And 0.707 times a total length daw of 2.5 meters. So convert na natin siya sa mm since mm squared ang area. So that will become 2,500 because 1 meter is 1,000 mm. And syempre, kailangan diameter natin ay naka-mm. So saan natin makukuha yung diameter? Remember that the given cross-sectional area is 1,250 mm squared, and we all know that area is also equivalent to pi over 4d squared. So makukuha natin si diameter from this area. So the given is 1,250 mm squared is equal to pi over 4d squared, and we have a diameter of 1,250 times 4 divided pi square root of that. So that will become 39.89 mm. So rekta na natin dito, 0.707 times 2,500, 39.89 over 4. So that is equivalent to 177.22. So the answer is letter C. And of course, if this is 177.22 and it is greater than 120, this scenario is a long column. Okay, so number 4. Determine the end fixity coefficient of a column set up having an overall length of 3 meters and effective length of 2 meters. So way back no sa ibang slides natin, we all know that the formula that involves the end fixity coefficient is equivalent length is equal to total length over square root of end fixity coefficient. So in order for us to get this n, it should be present these two, the effective length and the total length. So hanapin muna natin effective length. Ang sabi dito sa dulo, the effective length is 2 meters and the total length is 3 meters. So n is unknown, so that will be equal to 2 meters is equal to 3 meters. So cancel yung meters. Kailangan parehas ng unit yan, guys, para maging dimensionless or walang unitless rather. Parehas lang pala. So it will be square root of n. So that will become square root of n is equal to 3 over 2. So square both sides, of course. So that will be equivalent to 3 over 2 squared. So that will be 9 over 4. So the answer is letter A, 9 over 4. Okay. So proceed tayo sa 5. Yan, critical load. Sabi, what is the critical load of a steel column whose effective length is 10 meters and radius of 0.1 meters? E for steel is 200 GPa and the end fixity coefficient is 0.5. So the question is looking for a critical load, which is, we all know that FC represents the critical load and also equivalent to force times factor of safety. And of course, it will depend if this is a short compression, a long column, or short column. So check muna natin. Pero isa-isain muna natin ang given. Ang sabi, ang effective length daw ay effective length is 10 meters or 10,000 mm. And the radius is 0.1. So sabihin natin, gawin na nating diameter. So if the radius is 0.1, of course the diameter is 0.2 meters. So that is equivalent to 0.2 meters or 200 mm. Okay, so in order for us, check muna natin kung anong formula ang magagamit by using the first step sa mga ganitong problem, which is the slenderness ratio, and it is equivalent to 10,000 divided by radius of gyration, which is d over 4, and 200 over 4. So that is equal to 10,000 divided by 50 kasi 200 over 4. So the slenderness ratio is 200 and it is obviously greater than 120. So the problem is a long column. And syempre, kapag long column, kagaya ng sabi ko kanina, kapag mga columns problem, we wish to have a long column scenario kasi mas madaling tandaan yung critical force and has equivalent to pi squared EA divided by slenderness ratio squared. And of course, meron na tayong slenderness ratio which is 200. So check na to. And syempre, meron na rin tayong E which is 200 GPa or 200,000 megapascals or 200,000 Newton per mm squared. And we have this N fixity coefficient of 0.5. So I think hindi na to kailangan kasi meron tayong E. And of course, area is just simply pi over 4 d squared. So meron tayong E. So ang area naman natin is pi over 4 d squared. That is equivalent to pi over 4 times 200 squared. So isa-isa natin. So this is mm. So it will be mm squared in answer. So that was pi over 4 times 200 squared. And that is equivalent to 31,415.93 mm squared. So isa-isa natin. So the critical force will become pi squared times 200,000 Newton per mm squared times na nga lang natin, wag na yung dot, times this area which is 31,415.93 mm squared. So mm squared is cancelled. So the answer is in already in newtons divided by 200 squared, which is your slenderness ratio and which is a unitless term. So the FC is equivalent to pi squared times 200,000 times 31,415.93 divide 200 squared. And the answer is 1,550,314 newtons. But the question or the multiple choice is looking for kilonewtons. So just divide it by 1,000 because 1,000 Newton is 1 kilonewton. And there you have it. We have this critical load of 1550.31 kilonewton or simply 1150 kilonewton as advised by choices kasi walang mga decimals. So obviously the answer is and letter D. 1550 kilonewton. And ayan, last question. The piston rod of an air operated press has a length of 760 mm with its right hand end pin connected to the operating lever and the piston end of the rod fixed ended. The rod is made of a material whose SY is or yield strength of 250 megapascal, elasticity of 200 gigapascals. For a factor of safety of 2.0, determine the maximum safe compressive load of the rod in kilonewton if the diameter is 20 mm. So again, that question is looking for the maximum safe compressive load in kilonewton if the diameter is 20 mm. So we're going to draw muna the scenario. So kunyari meron tayong piston rod. Syempre kapag piston rod, ganyan yan. So ayan, piston rod. So medyo maarte, no? Pares lang naman pangit yung drawing. So we have this piston rod. Ang sabi, the piston rod of an air-operated press has a length of 760 mm. So, kunyari ito yung length. With its right hand end pin connected to the operating lever. Sabi, right hand end pin. Kunyari, ito yung right hand end pin. So, sabihin na, since this is an operated press, alam naman natin na kapag ganyan, yung mga nakikita natin sa Facebook na videos, yung may mga hydraulic press. No, ito naman is an air-operated press. Yung mga may pinipisa. No? So, kunyari, ito yon. Yan, kunyari, naka-pin. Yan, kasi ang sabi, connected to operating lever. Right hand end pin. So yan yung isang end. Dalawa lang naman ang end. So ito yung isa. End pin. So ito yung pin. Yan. Tapos, ang sabi, and the piston end of the rod. So ito yung piston end is fixed-ended. So sabihin natin fixed yan. Kunyari nakahinang. So this is fixed. So the scenario here is a fixed end and a pin end. So syempre, kung piston to nakalagay yan sa case. Yan. 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 Ayan. So the other end is a fixed end. So this is the rod. This is the piston. And this is the rod. And of course, ang sabi, the diameter is 20 mm. 20 mm diameter. Okay, ito yung drawing ng piston rod natin. Sensya na, hindi ganun agandaan. Kunyari, meron tayong object dito na pinipisa. Ayan. Ayan. And of course, meron tayong force dito. At meron din tayong force dyan. Okay, so the drawing is already completed. So the question is looking for determine the maximum safe compressive load of the rod in kilonewton with diameter is 20 mm. So F ang hinahanap. Maximum safe compressive load is either F or FC. So may given time factor of safety. So we're going to see. Okay, so anong una ulit natin? The first procedure is to look if it's either a short compression or a long column or a short column by computing the slenderness ratio. And slenderness ratio is equivalent to effective length over K. So how are we going to do this? So ang setup is a fixed end pin. We all know that the fixed end pin has effective length of 0.707 L. So that is equivalent to 0.707 times the total length of the rod is 760 mm. And of course, ito ulit, radius of gyration for a simple circular cross section, which is K is equal to D over 4. So that is equivalent to, the diameter though is 20 mm. So 20 over 4. The slenderness ratio is 0.707 times 760 divide 5. So this is a 107.464. So this is greater than 30, but less than 120. So this is a short column. So ito yung kinakatakutan nating medyo mahabang formula. Pero kakayanin natin yan since we're looking for the force only. And we all know kapag short column, meron tayong formula na FC, or critical force, is equal to force times the factor of safety, and has also equivalent to yield stress times area multiplied by the reciprocal of the J.B. Johnson's equation, which is 1 minus SY times slenderness ratio squared divided by 4 pi squared E. Ayan. So isa-isayin natin yung mga given. So si SY ba ay given or yield stress? Okay, si yield stress ay given, which is 250 megapascals. Of course, si area given, just a simply pi over 4d squared. Kasi meron naman tayong diameter, which is 20. SY given, LE over K, meron tayo niyan. E, which is 200 gigapascals. So everything is given. Isasalpak na lang natin sa scratch and calculator. Okay, so FC is equal to Fn is equal to SYA. So our SY is 250 megapascals. So that was Newton per mm squared. So tingin ko kailangan nating iusod ng konti. So FC is equal to, so we're looking for the maximum safe. So ibig sabihin ng maximum critical force then, because it is already multiplied by the factor of safety. Pero given naman yung factor of safety, but ito na lang, rekta na natin sa SYA times the reciprocal of JB Johnson factor. So it will become FC is equal to SY, which is 250. Dito na lang tayo mag-unit sa ilalim. Megapascals. Times pi over 4 d squared, which is mm squared. So cancel na to, guys. Times the factor 1 minus SY, which is 250. So that was megapascals, no? Times the slenderness ratio, which is 107.46 squared divided by 4 pi squared E. Ang E natin is 200 gigapascals. So kailangan natin siyang i-times sa 1,000 kasi ito ay megapascals yung SY mo dito. So yung ilalim mo should be megapascals here. So that was 200 times 1,000. Kasi in every 1 gigapascal may 1,000 megapascals. So ayan. So cancel, cancel. So unitless na itong loob ng bracket and cancel yung mm square dito kanina. So perfect. Ang unit na natira is in newtons. So the critical force or the maximum safe compressive load is equivalent to, unahin muna natin sa bracket, guys. 250 times 107.46 squared divided by 4 divided by pi squared divided by 200,000. 1 minus answer. So this is, para lang ma-recheck nyo, guys, in your own. This is 0.634. So times pa natin ng pi over 4 times 20 squared times 250. So the answer, the maximum compressive load is 49,823.16 newtons. And the choices is requesting for a kilonewton, obviously. So just divide it by 1,000. Kasi 1,000 newton in every 1 kilonewton. So the answer is 49.8. 49.82 kilonewton. So we may say that this is rounded off to 50 kilonewtons. And the answer is, ayan, letter B, 50 kilonewtons. Okay, so that's it for now, guys, para sa columns. And I hope marami kayong natutunan. So just visit our page. No, nag-post din ako ng formulas doon for the column, and may ginawa ako dong derivation ng formula para sa n fixity coefficients natin. No, that was 3 months ago and I shared it last night again. So ayun, guys, maraming salamat sa pagsama, and I hope matapos natin machine design before the board exam for 2022. I hope nakatulong ako sa inyo ng malaki. Salamat sa pakikinig. Good luck and God bless sa inyong review. Again, I'm Engineer HB and thank you for listening. Bye-bye.